Hi, welcome to my channel Wonderful Physics. And I decided to present before you another video of lecture series. And the topic is waves and oscillations. We have studied waves and oscillations. It is from the basic school level. And I decided to take this topic because I feel that waves, they are the most mysterious entities. The wave section or the topic wave, it is the most interesting and at the same time it is the most mysterious topic in physics. The first impression what you get when I say what is a wave, most of the students they answer that wave is something which is traveling in the medium and without the actual motion of the particles. It is a kind of disturbance that is traveling through the medium. Well, very good. This is the definition that we are used to learn from the very basic level. But I will try to learn with you and to discuss with you what actually is a wave. This question, the question is itself a mysterious question. Why it is a mysterious question? Because it is difficult to describe a wave. And why it is difficult to describe a wave? The reason is far more interesting. This is the essence of this topic. Why it is difficult to describe? Why you cannot describe it so easily as we can describe some other object or some entity. So I have decided to start from the beginning and we will consider some topics here. The first one is what is oscillatory motion, mathematical equations to describe oscillatory motion, what is a wave, how to describe a wave. Now, in most of the textbooks that we are used to study in the school and college level, they describe the chapter waves and oscillations, or one chapter is wave, other is oscillation. The first topic that they start with oscillation is the simple harmonic motion, spring motion, and there are many other physical examples of simple harmonic motion. Simple pendulum is there. But what I feel during my teaching or in the university level or in coaching or in tuition, wherever, I don't feel satisfied. And this is the essence of the topic, that when you are doing something, you are not very clear that you are not satisfied fully with the explanation of the topic that you are giving to the student. The student says, no, I have understood. This is a wave. Its disturbance traveling through the medium is a wave. Okay, it is all right. It is given in the book. The student is happy with the definition. He can fetch a large number of marks. He can solve the numericals. But it is difficult to feel this topic from inside. And in physics, unless you feel something, unless you feel the essence of the topic, you don't get the wonder that is behind this subject, that is behind the topic. So, to learn and to enjoy at the same time, we should understand, we should feel the things. Well, wave is something which you can feel. I will start with the basic topic, that is oscillatory motion, and why I am doing so I will tell you in the later part of this lecture series. So whenever we are saying about motion, we have studied many kind of motion: translational motion, circular, rotational, every type of motion. Now in any of the above three motions that we have described, there is a phenomena which occurs, and that phenomena is called the repetitive nature or the periodic nature. Repetition. Something is repeating after some time interval. Periods. Periodic time. Periodic motion. After a time span, the same event is again occurring in front of you. So whenever repetition is occurring in a particular manner, or the repetition process follows a pattern that can be described in a mathematical form, we say it is the periodic nature. Example, Halley's comet, Earth rotation. In all these situations, there are many more. Simple pendulum. In all these situations, something is occurring after a period of time. The same thing is occurring. Halley's comet, it has a time period of about 75 or 76 years. After this time period, this comet will be seen. So this phenomena of observing the comet is repeating itself. Earth rotation is a similar phenomenon. So this is how we define or describe a periodic motion in the sense of physics or mathematics or in the scientific sense. Now let us come to a very common, very simple example, and I will relate that example with something which we have learned in our study of types of motion. Suppose we are bouncing a ball, a ping pong ball, or any other ball. In this game, what you are doing, you are taking a ball, you are throwing it with some speed to the ground. It is striking the ground, again rising to some height, again falling. This is the game that some child is playing. In the process, the person is throwing a ball with some speed towards the ground. The ball strikes the ground and rises to some height and again falls on the player's hand, or the player catches it, whatever is the situation. Now if I analyze this situation from the point of view of kinematics, if I analyze the motion, write the equation of motion, so what equation I will write, it is known to us. We will write the equation for both upward and downward motion, and also see it graphically. This is the most important thing. We will see the thing graphically to get a sense of the periodic nature. Repetitiveness, it is the fundamental thing of many physical processes, repetition. And it is related to motion. And let us see how it is related to motion. Let us write the equations of motion of the ball during its upward, during its motion in the upward and downward direction. Let us write the equations of motion. So for upward motion, if the initial velocity of projection was u meter per second, then the equation of upward motion is, we know this equation, it is not something very difficult. This is h is equal to ut plus half gt square. Since writing equations in the word file during teaching, it takes a small amount of time. So in order to save time, I am taking the snapshot of these equations, and these equations are available everywhere. I have prepared a PDF file of equations that are required during the lecture. So I am taking the snapshot to save time. So this is the upward motion. Now what happens? at the maximum height h, the ball loses all its velocity, and it falls towards towards the ground or the player's hand. This is the motion. This is the phenomena that is occurring. Now let us write the equation for downward motion. So the equation for downward motion is, you can write I am writing here the general equation. We know that during the downward motion, the initial velocity is 0 because it has lost all its velocity, and it is dropping towards the ground. You can write u is equal to 0 in this equation. So equations in physics, what may from simpler to complex equations, they describe some process. You observe these two equations, and what you observe that mathematically there is only a change in sign in the direction of, and this change in sign is showing the change in the direction of motion. Remaining parameters are same. Parameters means the form of equation is same, and the second difference is that the value of u, initial velocity, is different in equation 1 and equation 2. Let us number these equations, it will be convenient. Equation 2, the equations differ in the sign of the half gt square, half, I am writing in the simple form, half gt square, and the value of u in both cases is different. Value of u in both cases is different. So this is the difference. Otherwise, the two equations, they appear to be same. There is no difference. Otherwise, the two equations are same in appearance. So whenever we are studying periodic nature or repetitive motion, these words same, again, they are very significant. As I feel, you will realize this thing too. In the motion, in the discussion of the periodic or repetitive motion, the words same, again, are significant, and you should understand the meaning. You should understand the meaning, not the literal meaning but the physical meaning. What physics is there in these words? So let us come to our discussion. Now the 1 and 2, they show the equation of motion. They are describing the motion of the ball when it was going upwards with some velocity, and when it is coming down towards the player's hand or towards the ground, whatever. U is different in these cases. Sign is different. The sign shows that the directions are different. One is upward, one is downward. You can take the down, and that plus minus sign is arbitrary. You can take that sign in your way. The important thing is that they are describing the motion in two directions, one upward, one downward. Now, what is the relation? The student may ask, why are you describing this equation? What is the relation with periodicity? Unless you ask questions, you don't understand what is going on. What is the relation with periodicity? I have learned periodicity, the oscillation of pendulum and rotation of Earth and Halley's comet. Now, how this equation is periodic, how it is related to periodicity? This is the question of the student. The student asks how this phenomena is related to periodicity, or okay, periodicity. What is the relation? This is linear motion, because the student is uh, accustomed, the student is used to the basic definition of periodicity. Let me change the sign, downward direction, and this is for upward. Let me tell you why I am taking this result. Now, if you plot the graph of displacement versus time for these two equations with some values that you are provided to you, you observe something. I am taking the graph from the NCERT textbook. You can follow any textbook. The main thing is that you should understand the concept. Let us draw the graph of the motion as described above with displacement and time as parameters, or what I want to say, or the displacement time graph. Let us, if I draw this graph, if you draw this graph, what you find is this kind of a variation. And the equation itself is showing that h and t, there is a t square term, so there will be a periodic variation, so there will be a parabolic curve. The curve will be parabolic. Now you see what I am trying to say. This curve, this graph, it shows that there is a kind of repetition if you observe the graph. Both the curved parts in this graph, they are sections of a parabola. And these sections, they are repeating. This is one part of the parabola, then again it is going, then again this one, then again this one, then again this one, then again this one. So a pattern, a geometrical pattern is repeating itself. A geometrical curve, a geometrical curve, it is repeating itself. So this is a kind of periodic motion. This is a kind of periodicity. And this example I have taken to show you the relation of mathematical equations with periodicity. The curve shows that the relation between the displacement, or write it like this way, in this way. The curve shows the section of a parabola which is expected from the dependence of x on t. This curve shows the section of a parabola which is expected from the dependence of x on t as repeating itself after some period of time. This section of parabola is repeating itself. A geometrical pattern, a definite geometrical shape is repeating itself after some time. The ball is thrown upwards. It takes some time to reach the maximum height. It is again falling on the ground, or on the ground. Again it is thrown, or it is bouncing back. It is again going to some height, again falling. So this going upwards, reaching a maximum height. Now try to relate this. The ball is the ball is thrown on the ground. It is moving to some height, losing all its velocity, again coming back to the ground. Again it is bouncing, going to some height. Again it is coming down. Again it is going some height. So this going to some maximum height, then coming down, and again it is going to this maximum height, some different maximum height if there is loss of energy. So what is happening? The motion is repeating. If the ball is assumed to lose, that it is, if we assume that the ball is losing no energy while striking the ground and going to the maximum height, it will continue to do this. This process will be repeated. So this is a kind of repetition, and this physical process which is repeating, going to maximum height and again falling, it is visualized as the repetition of a particular geometrical pattern. Now, what decides the geometrical pattern? It is obtained from the graph, it is obtained from the equation, that there is a quadratic dependence of x and t square. We have a t square term in the equation. So what is happening? That the ball is reaching a maximum height, then it is coming back to the ground again and again. It is going to some height, and again falling. So the process is repeating. In a pattern which is the geometrical, in a pattern which is described, I should write it like this way, which is described by the mathematical equation relating x and t. The relation between x and t is a quadratic relation, as there is a t square term, so the graphical representation is a parabola. The diagram above represents the geometrical form of a physical process, So your diagrams, graphs and equations, they are actually the visualization of some physical process. And the physical process is the bouncing of the ball, or make it more simple, is the rising of the ball to some height and then coming down from that height. So this diagram, it is the geometrical representation, it is the pictorial representation of a repetitive or periodic process, and this rising and falling, it is occurring in a particular time interval. This is the time period, or this is the time lapse in which the process is repeating. It will go to some height, reach the maximum height, and then again fall. This process takes some time. We can calculate this time. We know how to calculate. the process is occurring in some time, or we can say the process is repeating after some time interval, after some time interval, after some time interval. This time interval is the period of motion. This time interval is the period of motion. This is the period of motion. So this is a repetitive process. There are many such processes that repeat themselves after some span of time. They are all periodic in nature. The phenomena is repeating with time. The phenomena we are when we are studying kinematics, we are relating x, y, or displacement with time. Here we are relating a phenomena with time. Mind this word. We are relating an event with time. So this is an event, the occurrence of Halley's comet or rotation of Earth. So this is an event with time. We are relating an event with time. This much I will say. Now let us come to the most familiar example of rotation, oscillatory motion, periodic motion, vibrational motion, and that is the case of simple pendulum. Here you have the diagram of simple pendulum, and this is the basic example, the foundation of all periodic motions that we study. We all know the simple pendulum. We have a bob, metal bob, connected with a thread and suspended from a fixed point. And if this bob is displaced from its position, I will not describe what is this position right now. I will tell you, explain you what is mean and extreme position. Then it will come back again to its original position, go back to the other side, and again come to the mean position. This is one oscillation, we know. This is what we have been taught. Okay, it is very good. So let us learn what is this occurring, what is happening here. So we have learned the periodic motion, that the process repeats after some time. In case the body which is undergoing periodic motion, it has a position inside its path. Inside its path, if mind these terms, I will write everything. Inside this its path, there is a position where it is in a state that it is free from all external forces. It is free from all external forces. And that position is called the equilibrium position. Now, whenever a body or something is in the equilibrium position, it is in a state of maximum stability. Every object in nature has a tendency to remain in the undisturbed state. So when a body is in equilibrium, it is in the undisturbed state. There is no external force acting on the body, no external force, and it tends to remain in that state forever. But if the body is given even a small displacement from that position, there is something that tries to bring back to its original equilibrium position, and this gives rise to another situation. So we have the simple pendulum, and we will learn here what is the meaning of oscillation and the concept of oscillation in bodies. Of course, it is a periodic motion. Suppose we have a body which is undergoing periodic motion, which is undergoing periodic motion. If it is undergoing some motion, it will definitely, it has a path, as I described in this example above. This is the parabola or the geometrical pattern that we are getting between x and t square. It is the path of the particle. It is the path of the body that it is describing. X, relation between displacement and time. How x is changing with time. It is a path undergoing periodic motion. Then there is a relation between its displacement. Again, you should be careful about this. I am writing displacement, not distance. I am writing displacement. Think over it. Why I am writing displacement? I will tell you. Displacement and time. This relation describes the path or the trajectory of the body. Now suppose inside the path or trajectory of the body undergoing periodic motion, there is a point where the body is free from all external forces. So this is a point, this is a location inside the path of the body. Whatever path it is following, it is parabolic or circular, or it is not linear, parabolic or anything. Inside that path, there is a point where the body is free from all external forces. The position where the body is free from all external forces is called the point or position of equilibrium. This is the definition of equilibrium. This is equilibrium. At the equilibrium position, the body is totally free from external forces and is stable. It is stable. It is free from any external disturbance or external forces. It is stable and it has a tendency to remain in that position forever. It will not move. It will have no tendency to leave that position which is most stable. It will remain there forever. If there is some disturbance, what is the meaning of disturbance? I am telling you. Disturbance or any shift from this position of equilibrium, then there will be a force or factor that will tend to bring the particle back to its original position. It will try to bring back the particle to its original position. So whenever it is getting disturbed or it is shifting from its position of equilibrium, there is some factor, there is a force that is trying to bring back to its original position or the equilibrium position or the equilibrium position. Since this force has a tendency to bring back the body towards the mean position. So what it is doing is to restore or mean position. So what it is doing, or write it in this way, mean position towards the mean position. It is trying to restore the body to its position of equilibrium. It is trying to restore to the body to its equilibrium position. Restore means to bring back in the original situation. Equilibrium position or the original state. This force acting on the body is called the restoring force. That is why it is called restoring force, because it tends to bring back the body to its original position. It is restoring the system. What is since it is a force, it is a vector quantity, the direction of restoring force is opposite to the direction of displacement from the equilibrium position. This is the definition of restoring force. Now what happens in this situation? What is the result of this situation? Since the restoring force, it tries to bring back the body to its original position. So what happens? The body undergoes a motion which is called oscillation, or in the most simple language, it is the to and fro motion. It is neither shifting totally away from the equilibrium position, neither it is coming back and stopping at the equilibrium position. The restoring force is trying to bring back the body to its original position. This is how the oscillation take place. The body under the action of the restoring force, which tends to bring back the body to its original position undergoes a motion called the oscillatory motion, or in simple words, the to and fro motion. It is not decided where will the body go, whether it will displace from its original position forever, or it will come back to its initial position and stay there forever. It is not decided. It is in a state of oscillation. It is moving about. Every word is very important for, and it is relating to many situations in physics. It is moving about, it is oscillating about the position of equilibrium or the position of maximum stability. It is neither at this position of stability nor moving totally away from the position of stability. It is doing something around that point, around that equilibrium point. And this relates oscillation or vibrational motion to statistical sense also. So that we will cover up in the later sections. So the body is moving about or making to and fro or oscillatory motion around the mean position. Why we say mean position? This is also a very important concept. From school days, we see that the equilibrium position, it is also described in the books that this is the mean position. This is known by another term. I will tell you after small time. Around the mean position or equilibrium position. Equilibrium position. It is neither getting displaced away from the mean position, from the equilibrium or mean position, or mean position, neither it is coming back to the mean position and staying there forever. It is in a confused situation. This phenomena occurs with us also. We are confused what to do, neither going this side nor going that side. So this equilibrium position is also called the mean position. Mean is a mathematical word, or rather I should say it is a statistical term that describes average. Now what is the meaning of average? We will cover it. We will come. This is very interesting relation, mean position. For the time being, I am writing here mean is a statistical term. Is a statistical term. It is used in statistics, mean or average. So this is what is going on in oscillation or vibration. Examples of oscillatory motion, it is given here. You can see the diagram. This is the pendulum. This is another example where a small marble ball is kept at the bottom of a hemispherical bowl, and if you take this small hemispherical ball slightly to some one side, right or left, it will start oscillatory motion. You can visualize the situation. So these are the two very relevant examples of oscillatory motion or vibrational motion. Many times students ask, what is the difference between vibration and oscillation? So there is no demarcation line. Both terms mean the same. Depends on the frequency of oscillation. So this is what is oscillation. In the next lecture, we will go into details of this oscillation, of this topic. And please don't forget to like, subscribe, and share this channel for the sake of physics, for the sake of helping a community of teachers who are in trouble. So please like, share, and subscribe this channel. Thank you.